Right, this is the video lesson for Algebra 1D 12.5, Samples and Surveys. So in this lesson, we're going to classify data and analyze samples and surveys. So first thing we need to know is different types of data. There's quantitative data, which is data that has units and can be measured and numerically compared. And then qualitative is going to describe a category that cannot be measured numerically. So an example of quantitative would be their age, 13, weight, 214, time, 23 minutes. Qualitative is, again, category like hair color, brown, attitude, optimistic, zip code. All right, so the first problem is just asking you to choose between qualitative and quantitative. Favorite movies, is that something that can be numerically measured? No, so that is qualitative. Man, my cursive is bad. Does that even look, can you even read that? Sorry. Qualitative, there we go. Numbers, we already know the answer to this then, of students in different schools who take Spanish. This is going to be quantitative because it has unit numerically compared. And then football jersey numbers. Even though, okay, I kind of tricked you in this one, or confused you in this one because I said, oh, look, numbers, then we know it's quantitative. This one says football jersey numbers, so that makes us think it would be quantitative. But football jersey numbers just don't mean anything as a number, right? There's no purpose to, the numbers don't mean anything. You can't add them, you can't compare them numerically. So this is actually qualitative data. So I'm glad that they had this example so we can talk about the difference between them, right? It's data, even though it's numerical data, it's not a measurement. So the units that can be measured, right? A football jersey number is not something you can measure. Numbers of students in different schools who take Spanish can be measured. All right, hopefully that's clear. Try these two on your own. You probably don't even have to press pause. I'll just talk a while here, and while you look at that, cost of CDs, try to think of what that is, qualitative or quantitative, and then eye colors. Give you a second to think about it. Okay, costs, that's something that can be measured, so quantitative. And then eye color, not something that can be numerically measured, qualitative. All right, do we get the difference between qualitative or quantitative? Hopefully you all said yes. Okay, moving on. Now we're going to talk about the difference between univariate and bivariate. The kind of data you're working with determines the type of graph you'd use to display the data. So a set of data that uses only one variable is univariate, right? Una being one, variate being variable. And then a set of data that uses two variables is bivariate. Bi means two. And then variate is variable. Okay, so let's look at this first problem. Second problem is each data set univariate or bivariate? So the A says the atomic weights of the elements in the periodic table. And the variable here is just atomic weights. So that is one variable. So this is univariate. And then B says the edge lengths and the volumes of cubes. So there are two variables here. So this is bivariate data. The data set is bivariate. Okay, so the ones for you to do on your own, again, you don't need to press pause. Let's just think about heights and weights of mammals. Is that one or two variables? And then D, the cost of internet service from several different providers. Is that one or two variables? Come up with an answer. Okay, here you can see this is two variables, so this is bivariate. This one's a little bit more confusing, right? It's from several different providers, but the variable is cost of internet service. There's just one, so this is univariate. Okay, moving on, some more vocabulary. Statisticians collect information about specific groups of objects or people. The entire group that you want information about is called a population. So let's say the population is represented by this circle here. This whole circle is population. When a population is too large to survey, the statisticians survey a part of it to find characteristics of the whole. So you take a piece of it and sample this, right? This is called a sample. And then here are three different sampling methods. It says next page. This is not the next page. This is from your book. When designing a survey, you should choose a sample that reflects the population. Okay, so if you have a random sample, right, you're just going to survey that people in that population at random. So an example would be survey people whose names are drawn out of a hat, right? Or if you're in, I think maybe in this class, yes, we have used it. When I just randomize and I just pick a student randomly with that app. Systematic is going to be you select a number n at random, then survey every nth person. So, right, every other person or every fourth person or every 10th person, every 100th person, depending on how many people are in your population. So here's an example, select the number 5 at random, survey every 5th person. So you have to pick that number at random. That's called systematic. Stratified is if you separate a population into smaller groups, and then each smaller group has a certain characteristic. Then survey at random within each group. So you could separate a high school into 4 groups by grade level, and then survey a random sample. Survey a random sample of students from each grade. That would be stratified. Okay, let's look at problem 3 with that in mind. DVD rentals. You want to find out how many DVDs students at your school rent in a month. People don't really rent DVDs anymore, do they? You just watch stuff on Netflix or something. But you used to, back in the day, have to go to a store and rent a DVD. So you'd actually go to the store and see, oh, what movie do I want to watch? And then you'd say, oh, you'd find one, and then you'd go to the front and say, I want to rent this DVD. Anyway, this book is old. You interview every 10th teenager you see at a mall. What sampling method are you using, and is this a good sample? So this is saying your population. Right, first you need to think about the population. This is students at your school. Okay, and then you're going to be interviewing every 10th teenager. So that is systematic, right? Because you have a system. You picked 10 at random. And this is all students at the mall. What sampling method are you using? Systematic. Is this a good sample? If you wanted to find out students at your school, does it make sense to in a randomized sample people at the mall? No, this is not a good sample. There could be kids at the mall who aren't in your school. So you could have teenagers in your sample, not from your school. I don't know why I'm cursively writing this. You don't need to see that. You know what I'm saying? Can't even read my handwriting. Okay, sorry. So no, right? Because if you want students at your school, you need to systematically interview or ask people questions from your school. Okay, so here's one to try on your own. You revise your plan. So same idea. You interview all students leaving a school assembly who are wearing the school colors. Will this plan give a good sample? Explain. Again, you don't have to press pause for this one. But does that make sense? So this is going to be now, it sounds like it is stratified, right? Because you are taking out a group of, in a category, right? Wearing school colors, right? But that's the only people you're using. So this would be stratified. It didn't ask that. Kind of stratified, right? But remember, stratified says you take a random sampling of them, but you also take random sampling of every other category too. This is just one category. So this is not a good sample, right? Because then you would just be asking people with wearing school colors, and you were not asking a random number, you're asking all of them. And so your sample would just be what the people who wear school colors would be. So it wouldn't be a good sample of everybody. Okay, moving on, another vocabulary word, bias. So a survey question has bias when it contains assumptions that may or may not be true. A bias can influence opinion and can make one answer seem better than the other. Survey questions must be carefully worded to avoid bias. So let's look at an example here. A reporter wants to ask what kind of movies are most popular with local residents. The reporter asks, do you prefer exciting action movies or boring documentaries? This is pretty obviously, the questions are biased, right? No one's going to say, oh, I love boring documentaries, right? So this question is most certainly biased, yes, because they're making the action movies sound so exciting and happy and trying to bias you or make you pick this answer and making this sound like a bad answer. So this is biased. That's why it's biased. Okay, and then this one for you to think about on your own. How can the question in problem 4 be reworded so it is not biased? So take a second to think of how you would ask this question without biasing it. And then, let's see. Obviously, the easiest answer would be, do you prefer action movies or documentaries? Take out the adjectives. Describing how you feel about them, right? And just, do you prefer action movies or documentaries? Nothing is biased, right, for that example. Okay. And the last problem. You want to determine what % of teens from 14 to 18 watch wrestling on TV. At a high school wrestling match, you ask every third teenager whether he or she watches wrestling on TV. How might this cause bias in the results of your survey? Well, if you're at a wrestling match, people are there because they like wrestling, right? Or at least high school wrestling. So there's more of a chance that they're going to watch wrestling on TV. So the bias in the results are going to make it seem like more people like wrestling than they do. Because if you're at a high school wrestling match, the chances are that they like wrestling on TV is higher than just, a teenager who's at the mall at the same time. They probably aren't as interested in wrestling. And so this last example, you want to know how many of your classmates have cell phones. To determine this, you send every classmate an email asking, do you own a cell phone? How might this method of gathering data affect the results of your survey? Think about that for a second. And let's answer right. If you're sending them an email, you're assuming they have a computer to get the email, right? Or a phone to get the email, right? Some of you can get your email on your phone, or most of us can. Right? If you don't have a phone and you don't have a computer, you can't get the email, so you can't answer that. Right? So instead, you might want to ask them in person while you're at school. Because if they don't have a phone, they might not be able to get an email. Okay. That is it for this lesson. Here are your practice problems. Enjoy.